I'm a game changer. I'm a risk taker.
Hello, Golden Brains team created by Technorobirun students in 2018. We are from Iran. Our team participates in internal competition like Iran Open and Junior Cup 2021. We participate in Junior Soccer Open Weight.
Due to some problems, our team realized 20 hours before the announcement of the challenge detail that this part of the competition is scheduled to take place on that date. Since our schedule is for the competition until November 25, one of our robots was not ready to participate in this challenge at all. Immediately after realizing the challenge, we prioritized the completion of the second robot and tried as much as possible to bring it to activities 1 and 2. But unfortunately, we were getting closer and closer to the challenge deadline. We decided to write and send the only challenge which can be done with a robot.
In designing and building the robot, the detail of the different parts were very important to us, and we tried to be as accurate as possible in the design. For each person in the team to have a responsibility and do something, at the beginning of the project we held a meeting and each person found a role. Mechanics, we tried to revolutionize the design of spin and shooter and make significant change compared to our previous generation of our robot. We use the brushless motor for a spin because these motors have a high speed and we can use their speed to apply more force balls. More force makes it easier to hold the ball in front of the shooter in oblique movements. This helps us to more easily direct the ball toward the opponent's goal. For the shooter, we have used a solenoid that uses the magnetic field to throw the shoot core out, and after the shot, it was pushed back by a spring force to prepare for the next order.
These solenoids had problems that forced us to test a new design in the shooter. The solenoids available to us during a lot of currents and we had to use a voltage booster to power it to meet our needs. Our new shooter design is inspired by one of the teams that competed in the RoboCup Worldwide 2021, which uses a spring force to hit the ball and then uses the stepper motor to push the core of the shot backward.
In the robot electronics part, we also considered some parameters and tried to replace the obsolete parts of our previous generation of robots as much as possible. And after the necessary research, we found a suitable replacement. For the motors and drivers, which were one of the main problems of our team in the previous generation, we changed both of the motor and drivers and replaced them with alternative model available in Iran. Our new motor is spinning at 500 RPM using 12 volts. To start this engine, an 𝗥𝗚20D driver is used, which can start two motors at the same time. For the electronics section, we intended to use modules and stable boards as much as possible to minimize noise. This driver has a good dimension that made it possible to place it on the robot separately.
Rangefinders are another of our change. In the previous generation we used Sharp, but now we prefer to use SRF. Sharp have a limited vision and do not give us exact numbers on the field. SRF modules, the base on sound, give us the exact distance of the robots to the wall and help us to score the ball and place the robot in the goalkeeper area.
In this robot, we tried to replace everything we had problems with before and find a replacement for it. As much as possible, we tried to use the experiences of other teams that they shared with us in their TDPs and find a replacement that has already responded in this league. But to promote the robot, we will introduce the field that we are working hard for that and used for the first time, or we tried to be one of the first teams to bring this idea to this league: shooter and movable camera. The shooter is described in mechanics section, but our robot span tilts. In this structure, we use two servo motors that move the camera in yaw and pitch axis, who helps us to detect the ball. Based on the location of the ball and the distance of the ball from the robot can decide how to move the motors. After the ball lands in the robot's ball capturing zone, the camera immediately raises its head and looks for a goal. After finding the goal, the robots move toward the goal with sub-movement. Our robots are not the same, and there is a big difference in the detection of the ball. One of the robots finds the ball using a convex mirror and the other uses a pan tilt. The convex mirror gives a 360-degree view of the surroundings. The advantage of our mirror robot is that the robot can easily detect the ball in the field of view, and the advantage of our direct camera robot is that without rotating the robot, it detects the ball in a straight range and has no lead. These robots have different performances in different roles, which named as goalkeeper and striker, so that if the attacking robot is mirrored, it may not recognize the ball for it, but our direct camera robot can easily see the ball from behind the field of play and tell the attacking robot where the ball is concerning the opponent's goal. The direct camera robot monitoring the ball always and everywhere and can react better in the goal. But if the mirror robot's role as a goalkeeper due its limited vision, it may recognize the ball late and does not have a good time to react.
In this process, perhaps the most important thing we learned was teamwork. From the first day we started working together, there were problems. Over time, our teamwork increased. During the process of building the robot, we had to learn to work with different software for different parts. To design the shooter core, we tried to work with SolidWorks software as needed, and we used 3D printing